Alright, so I've got some really great news today, and that is that there is an after work video, and you are watching it right now. I've been skipping these lately, I kind of haven't realized how much time I had spent with kind of new. I used to be like back when I was working my old job, I would walk to and from my job every day, which was like a 25-minute walk. Actually, no, it was like 35 minutes. So I would walk over an hour a day. I'd come back from work and I would go to the gym at night. I would do like a swim. So I exercised quite a bit. And then I kind of had a regular, work would like buy extra meals and stuff. So I was kind of struggling with my weight a little bit, but I would, for the most part, have like regular things to eat. I guess long story short, I was in pretty good health when the pandemic came, but then everything I was doing changed. I wasn't exercising anymore. I was eating okay, but like I had more opportunities to eat, so I went through a pretty big weight gain and probably quite a bit of muscle loss too in the 5-6 months that I just kind of was in limbo land, thinking, oh well, are things gonna go back to normal? Are things gonna be different from now on for the rest of my life? And I've kind of come to the realization that we're just in a whole new, things are not going to go back to the way they were. So I built a new, so I'm in the process of building new habits that are really gonna lead me to a place I want to be. So unfortunately that has meant skipping a few after work videos and even a lunchtime video here and there. But that was just because I needed to do a car maintenance or some errand like that. But the long story short with this is just I'm feeling really good now that I got those new habits kind of on the oven, turned me into kind of more the person I was and the person I kind of has my health more, because I've always told myself oh, once I finally get the chance to work from home for an extended length of time, that's when I'll really take control, really get a lot healthier, get a lot happier, because there'll be more under my control that I can do, and I'll save time that I would have spent commuting to and from work. And these last 5 months, I didn't really kind of act on that because I thought things were just gonna, the light switched to off. I thought it was just gonna switch right back on eventually, but it's been about 6 months. I started working from home on the 16th, and I don't even work in the same job anymore. I live in the same apartment, thankfully. It looks like there might be other people having trouble with that, but if I'm putting my old habits on hold, especially the ones that were really beneficial to me, such as exercising, with the intention of resuming them as normal, I really got to dispel myself of that and build new habits that are going to be better. And that is what I have began to do this week. But as I mentioned, that unfortunately did mean skipping a few after work videos and weekend videos. So hopefully I can get those back up and running as soon as possible. But until then, I'm just kind of happy I am doing this video now, so let's make the most out of it. We're going to be learning about RSVP, bandwidth constraint configuration. So let's start it off the same way as I would start off any topic. We'll go to the lab, and we'll use help apropos because that will be available during the exam. So another thing I have struggled with quite a bit is whether or not it's a good idea to keep studying for this exam. Can I take it? Will it be beneficial for me to take it? And the answers I've come up with that is It looks like it is going to be offered remotely. They just don't have it available yet because they're testing it, they're phasing it out. It will be beneficial to my career because it's an expert level exam. That's, I think, really shows you have the gumption, you have the grit, you have the drive to do the job at a really, really high level. I think it's an endorsement of character as much as it is an endorsement of skill. And not only that, I am going to kind of change my plans and only take one attempt. If I fail, I fail. If I pass, awesome. But because of that, I'm going to now plan to take the test when I would have planned to take my second attempt, because before there was a incentive for me to pass the test by the end of this year. I no longer have that incentive, so the timeline for me, now there is an artificial time limit I'm putting on myself. I don't want to work on this for any longer than this year, just because there's too many other things to learn. But now that I'm taking it when I had initially planned to take my second attempt, I'm going to get a few more months of study, which I'm really desperately going to need. Okay, so let's start this off. Okay, so this is RSVP bandwidth constraint configuration. So a little bit difficult to find a keyword for this, but I think I'm just gonna stick to help topic. Oops, and it's gotta be pipe match. And then RSVP, we'll see what comes up for that. Okay, so we've got a number of things, but we're looking for bandwidth constraint configuration. So don't really see anything. Let's try bandwidth or band. Ah, here we go. So this looks like a relevant topic, RSVP bandwidth. So yeah, let's read this. This might not be everything, but I think it's a good place to start. Configuring the bandwidth for bypass LSPs. You can specify the amount of bandwidth allocated for automatically generated bypass LSPs, or you can individually specify the amount of bandwidth allocated for each LSP. To specify the bandwidth allocation, include the bandwidth statement, bandwidth BPS, bits per second. For automatically generated bypass LSPs, include the bandwidth statement at the following hierarchy levels. Edit protocols RSVP interface, interface name, link protection. Edit logical routers, logical router name, protocols RSVP interface, interface name, link protection. For individually configured bypass LSPs, include the bandwidth statement at the following hierarchy levels. Edit protocols RSVP interface, interface name, link protection, bypass, bypass name. Edit logical routers, logical router name, protocols RSVP interface, interface name, link protection, bypass, bypass name. If you have enabled multiple bypass LSPs, this statement is required. See also configuring the maximum number of bypass LSPs. So we do have bypass LSPs left over from the previous example. I thought. Well, I guess not. So we have, I think this is what I thought was a bypass LSP, but it looks like it's a standby. Or maybe there was one in a previous one, but let's take a look for a better documentation. So let's search for cons. Let's see if anything about constraints show up. Okay, I don't see anything, so let's look for CSPF. Okay, so this looks good. I think I've read this one before, but it looks like it's short enough just to read it again. Disabling CSPF for bypass LSPs. Under certain circumstances, you might need to disable CSPF computation for bypass LSPs and use the configured explicit route object, ERO, if available. For example, a bypass LSP might need to traverse multiple OSPF areas or ISIS areas, preventing the CSPF computation from working. To ensure that link and node protection function properly in this case, you have to disable CSPF computation for the bypass LSP. You can disable CSPF computation for all bypass LSPs or for specific bypass LSPs. To disable CSPF computation for bypass LSPs, include the no CSPF statement, no CSPF. So yeah, that's not super useful. Let's do a Google search and try to find the perfect documentation for this. So this is RSVP bandwidth constraint configurations. We'll do Juniper RSVP bandwidth constraint configuration. Okay, here's, I'm at 0. That's sometimes pretty good. Okay, so we've got a number of things to look at. So this looks like it could be it, because this is configuring bandwidth prescription percentage, and that would definitely constrain the bandwidth. So I think I'm going to keep this one. Let's see if this link takes me down to that particular section. Okay, it does. So yeah, this is going to be a really good one, I think. All right, let's try to find some more. Okay, let's go to the top level of this entire guide. And yeah, so we'll go to MPLS Applications User Guide, expand all, and then we'll do Constraint. Oh, let's do Bandwidth. Okay, so this looks promising, just this bandwidth command. Let's see if there's any related documentation. So, yep, looks like there's many related things. Okay, those don't look so good. I think that one was pretty darn good so far, so we'll just keep that one there. Hopefully get through the whole thing, and this might be a one video topic because it seemed pretty simple. Okay, so this is CSPF, so RSVP bandwidth constraint configuration. So I don't think, I don't think this really has to do with RSVP. Yeah, CSPF applies to either. So I think the more specific one is going to be for the LSP itself. Yeah, I think this is definitely, yep, and this is all about RSVP, so this is so far the best. So it might be good to just read about this though. But if it's addressed in a different topic, I'm definitely not going to add that. But if it's all on its own, high and dry, yeah, I don't see CSPF covered anywhere else, so it might be worth just a quick read on that to make sure it's all clear. Okay, so I'll add this one to the list. Okay, and now let's move on and try to find some more resources. Here we go. Imposing bandwidth constraints. This looks perfect. So, isn't there a way to like? I'll just do this. All right, and then I can use that as a search term. So this is definitely going to be one. LSP bandwidth management, that looks good too, page 55. Oh, that was it right there. Yeah, LSP bandwidth management. So that's for static. We need it for RSVP. You know, they might be talking about most fill, least fill, random, bumped into that a bunch of times. So it looks like this whole thing is pretty good because this, well, actually never mind, because it's applied to the label switch path, it's not applied. Oh, but I'm forgetting, if it's a label switch path, then it is RSVP. Yeah, so this is policy-based LSP mapping, and then we've got LSP bandwidth management. So it's definitely going to be this. Okay, this doesn't look like as kind of polished as a resource. It looks like someone's personal presentation. So I'm not sure this is going to be a resource that's relevant to this test. Okay. Okay, so I think I've got all my resources now. I'm just going to be using these four. This one's a bit of a extra resource. It's just some more information about a topic I'm not 100% clear on, but the topic isn't necessarily on the curriculum. It's just certain aspects of the curriculum rely upon it. It's like, typing is not on the curriculum either, but if you can't type it all, it takes you an hour to enter a command. So it's kind of like that. I'm just curious to learn about it, and knowing the details of CSPF I think will be in some way useful. All right, but let's get started with this first document here. So this is configuring the bandwidth subscription percentage for LSPs. By default, RSVP allows all of a class type's bandwidth, 100%, to be used for RSVP reservations. When you oversubscribe a class type for a multi-class LSP, the aggregate demand of all RSVP sessions is allowed to exceed the actual capacity of the class type. If you want to oversubscribe or undersubscribe all of the class types on an interface using the same percentage bandwidth, configure the percentage using the subscription statement. For a list of hierarchy levels at which you can include this statement, see the statement summary section. To undersubscribe or oversubscribe the bandwidth for each class type, configure a percentage for each class type, CT0, CT1, CT2, and CT3. Option for the subscription statement: when you override a class type, an LOM is applied to calculate the actual bandwidth reserved. See class type oversubscription and local oversubscription multipliers for more information. For a list of hierarchy levels at which you can include this statement, see the statement summary section. Percentage is the percentage of class type bandwidth that RSVP allows to be used for reservations. It can be a value from 0 through 65,000%. What? Okay. All right. I mean, I guess I'm more used to seeing 0 through 100%, but I guess if you have 200%, I guess that's valid. You specify a value greater than 100, you are oversubscribing. Okay, so it looks like that's a huge like range with which you can oversubscribe. You are oversubscribing the interface or class type if you go from 101 up to 65,000. The value you configure when you oversubscribe a class type is a percentage of the class type bandwidth that can actually be used. The default subscription value is 100%. You can use the subscription statement to disable new RSVP sessions for one or more class types. If you configure a percentage of 0, no new sessions, including those with 0 bandwidth requirements, are permitted for the class type. Existing RSVP sessions are not affected by changing the subscription factor. To clear an existing session, issue the clear RSVP session command. For more information on the clear RSVP session command, see the CLI Explorer. So before moving on, I'm going to take a look at this command. I believe it was subscription. No, it was percentage. So let's find that percentage command. I'm going to do a help apropos pipe match percentage, and we're not going to narrow it down by help topic because we want to see actual commands as well and not just references. Okay, so I don't see anything like that. So let's go into config mode and try that. I think it will have the same hits. No, it looks like it was quite a bit different. Yeah, a lot of different hits. That's something I might want to get used to doing, is help apropos within the configuration hierarchy. Yeah, because look, there's a lot of extra help available. Well, that's good to know. I actually didn't know that. Alright, so it's kind of too much output for me. So I'm going to abort that. And I think I'm just going to keep reading. Well, actually, no. I'm gonna go into the RSVP configuration, and I'm going to see if I can find this percentage command. But I'll do it on PE2 since PE1 is freaking out on me. So it's going to be edit protocols RSVP, and let's see if there's anything to do with a percentage. Nope. Let's try top edit protocols MPLS, show pipe display set relative. Okay, let's actually go to PE1 because I think there's no LSP on PE2. We only had a unidirectional one. We weren't concerned about moving actual traffic. We were more concerned about understanding how LSPs are formed. So we only built one. And it looks like I'm back. So let's do a show pipe display set. And yep, now we've got a label switch path here. Over here we didn't have one, so let's just focus on this. Okay, there we go. So deselect on bandwidth failure, deselect active path if it cannot meet the bandwidth constraint. So it looks like we've got all sorts of commands that have to do with this. Sync active path bandwidth, signal standby path with bandwidth obtained from active path. So let me just do a help apropos pipe match bandwidth. Or let me try this. Help but in any case, we do have that bandwidth command here. We've got a number, yep, and we've got the CT0, we've got the classes, traffic classes. Yep, so it is aligning with what's here. Let's continue reading. Constraints on configuring bandwidth subscription. Be aware of the following issues when configuring bandwidth subscription. If you configure bandwidth constraints at the added class of service interface name hierarchy level, they override any bandwidth configuration you specify at the edit protocols RSVP interface name bandwidth hierarchy level for the diffserv-te. Also note that either of the COS or RSVP bandwidth constraints can override the interface hardware bandwidth constraints. If you configure a bandwidth subscription value for a specific interface that differs from the value configured for all interfaces, by including different values for the subscription statement at the edit protocols RSVP interface name and edit protocols RSVP interface all hierarchy levels, the interface specific value is used for that interface. You can configure subscription for each class type only if you also configure a bandwidth model. If no bandwidth model is configured, the commit operation fails with the following message. Edit protocols RSVP interface all. Subscription. RSVP must have a diffserve-te bandwidth model configured when configuring subscription per traffic class. Error, configuration checkout failed. You cannot include the subscription statement both in the configuration for a specific class type and the configuration for the entire interface. The commit operation fails with the following error message. RSVP cannot configure both link subscription and per traffic class subscription. Alright, so let's try adding those in and then seeing if we can get the failure just as they had listed there. Okay, so it looks like we've got a similar help menu that we had up here. We've got the subscription, link bandwidth percentage, but here we've got bandwidth, we've got the classes available as well. So yeah, let's just set subscription, oops. Okay, well let's pick one of these options. Let's go with CT0, and then let's set it at 100. Which 100 is the default, so let's set it at 110. Okay, and now let's do a show pipe compare. Make sure we've got those changes. We'll do a commit check, and we'll get to this first message here. Because we don't have the diff-de bandwidth model configured. Yep. So must have a diff-serve-te bandwidth model configured. Let's see if there's help apropos for this. Okay, so yep, we got it for the bandwidth model. So let's take a look at what pops up here. Give that a quick read. Configuring the bandwidth model. You must configure a bandwidth model on all routers participating in the differentiated services domain. The bandwidth models available are MAM, extended MAM, and RDM. Maximum allocation bandwidth constraints model, MAM, defined in RFC 4125. Maximum allocation bandwidth constraints model for diff-serve aware MPLS traffic engineering. Extended MAM, a proprietary bandwidth model that behaves much like standard MAM. If you configure multi-class LSPs, you must configure the extended MAM bandwidth model. This one is probably my favorite model because it's the Russian dolls bandwidth allocation model, RDM, and it makes efficient use of bandwidth by allocating the class types to share bandwidth. RDM is defined in RFC 4127. Russian dolls bandwidth constraints model for diff-serve aware MPLS traffic engineering. So they say never to judge a book by its cover. but they don't say to never judge a bandwidth model by its RFC title. So therefore, my favorite bandwidth model is RDM. To configure a bandwidth model, include the bandwidth model statement and specify one of the bandwidth model options. You can configure the statement at the following hierarchy levels. So edit protocols, MPLS, diff survey for Q. Let's go in there and take a look. There we go. Bandwidth constraint model. Okay, so let's actually get this to work here. So we're gonna go with RDM, the Russian dolls model, because why go with any other one? And then we will go with let's see here. Yep, we'll add this subscription command. Okay, and then we're going to need to choose an actual Q, CT0, and we'll choose a value. We'll go with 199, and we'll do a commit check, and hopefully it will work now. Although we might. Okay, so the configuration check succeeds, but I do think that this command here, let me do a show pipe compare. Might be required on all of the routers in this, where this LSP goes over. So even though it will commit, it won't work as intended until that is done. I believe, I don't know for sure, but that is my understanding of it. Okay, so now let's get another error message by adding the bandwidth statement, and once that is on there, we will see that it will conflict with the subscription statement. Oh, well, okay, so I guess that's not what this means here. I thought it meant that you couldn't have those two commands together, but obviously that is not what it means. So, yeah, I guess I'm just not sure what it means. So you cannot include the subscription statement both in the configuration for a specific class type and the config. Oh, I see. Okay, so I think I get it. So let me do a delete of that last command I put in. So we're going to do edit here, and then we're going to do a delete of this last command. Perfect, okay. So now we're going to try to trigger this second error by going edit protocols, RSVP. Okay, so you cannot do it for an entire. You cannot include the subscription statement both in the configuration for a specific class type and the configuration for the entire interface. So here's the configuration for all of the interfaces. So we've got that command subscription here. Oh, I think these are the two options. So I think if I do a rollback 0, and then I go back to edit interface all, and I do set subscription, instead of having to pick one of these, it looks like I can do it without picking one. So let's do that. Well, let's go with 198. Yep. So if I do a commit check, that's gonna go through. Perfect. But what I can't do, and that's what this second error is saying, is I can't set the subscription bandwidth level to a value that applies to the whole interface as I just did, and then also go back to one of these queues and set it. That's how that second error will come up. Cannot configure both. Oops. Must have a different bandwidth model configured when configuring. Oh, did I actually commit my? Let's see here. Show pipe compare. Let's set the bandwidth model. Or let's do a show protocols relative. Do I have the bandwidth model? Okay, I think I remember what to do. It's MPLS. Oh, set protocols and MPLS. Oh, diffs. It starts with a D. Perfect. Bandwidth model. Oh, right, and then we got to choose one. We'll go with, I don't know, that might be a bit too provocative, trying to keep this channel, well, I did need to specify whether this channel was for kids or adults, and I specified it for adults, so let's go with the Russian dolls model. Alright, so we cannot configure both. Aha! I did it! So of course we got the first error that time because we didn't enable diff serve. We didn't enable a MPLS diff serve TE traffic engineering bandwidth model. We didn't choose one of the three available. But this second time around, now we have that there. So what I originally thought would trigger it now triggered it. The reason it didn't trigger it the first time is because this first error overrode it, and we only got the error for that before we could even get to the next one. So cannot configure both link subscription and per traffic class subscription, just as it says here. Perfect. Okay. So I think that's going to be it for this video. I think I'll come back and give this one a second one. It's just been kind of more interesting than I thought it would be. So I think it's worth at least another video. So thanks for watching, and I'll see you in the next one.